Okay, I believe this was the question we were working on at the end of last class. So this should already be in your notes. And we know that A and B has to do with F prime, and C and D have to do with the second derivative, F double prime. Now, I can't remember exactly how far we got. I think we answered A and B already. Is that right? Did we get to C and D? We did C and D also?
Yes.
We ended up at D.
Okay, so let me just reproduce a little of what we had. We had the first derivative, F prime of X equals 3x squared minus 6x plus 3. And when we did a sign chart for that, we ended up with a sign chart for F prime. So we had this with 0 at x equals 1 and positive over here and positive over here. And so it's going uphill, uphill, flattens out at 1. We saw that it's increasing actually from negative infinity to infinity. The second derivative is 6x minus 6. We saw that that's also 0 at 1. And it is negative over here. Yeah. And positive over here. So it's concave down over here, and concave up over here. We had a point of inflection at x equals 1. So I guess we wrote all that stuff down. So in part A, it's increasing everywhere. In part B, we have our critical point at x equals 1, which is neither a max or min. In C, we said it's concave up. From 1 to infinity, oops, and concave down negative infinity to 1, and we have a point of inflection at 1. Now let's go back to E. So intercepts, x and y intercepts. So for our x-intercept, or x-intercepts, there may be more than one. We'll set y equals 0. Y is just equal to the whole function f of x. So x cubed minus 3x squared plus 3x equals 0. We can factor out an x. So x times x squared minus 3x plus 3 equals 0. So either x equals 0 or this thing equals 0. X squared minus 3x plus 3. equals 0. So that doesn't factor nicely. Let's go ahead and use the quadratic formula on it. So x is equal to negative 3, which is 3, plus or minus the square root of negative 3 squared minus 4 times 1 times 3 all over 2 times 1. 3 plus or minus the square root of 9 minus 12 is negative 3 all over 2. As soon as we see that minus 3 there, we know that this has no real roots. So the only place it crosses the x-axis is at x equals 0. And our y-intercept kind of already know what it is. Cross the x-axis at x equals 0, cross the y-axis at x equals 0, but let's just go ahead and do it. Let's set x equal to 0, and we end up with y is equal to 0 cubed minus 3 times 0 plus 3 times 0 squared plus 3 times 0. Anyway, that equals 0, as we knew before. And we're just about ready to do f. I'm going to put my y-axis right underneath my 0. Put my x-axis over here. I'll make the marks on my x-axis line up with my sign charts for first and second derivative. I know it crosses the x-axis and the y-axis at x equals 0. Let me look around for other points that I should mark on the graph. I have a critical point at x equals 1, and I also have an inflection point at x equals 1, so I better figure out what's going on at x equals 1. So x, y. If I plug in x equals 1, then y equals 1 cubed minus 3 times 1 squared plus 3 times 1. So 1 cubed minus 3 times 1 squared plus 3 times 1. That equals 1. So it goes through the point 0, 0, and it goes through the point 1, 1. So we know those 2 points on the graph. That's not that much help. I mean, for all we know, this could be a straight line. But we have a lot more information up here. So what we're going to do is take all this information that we have about where it's going uphill, where it's going downhill. It doesn't go downhill at all. And what its concavity is, and use that to help us synthesize the graph. So we're going to break it up into parts. First time something changes is at x equals 1. In fact, that's the only time anything changes. So from x equals negative infinity all the way to x equals 1, we are increasing uphill to the right on a hill. So it's curving downward, it's concave down. Increasing on a hill, it goes through this point, and it goes through that point and levels out there. So increasing on a hill looks like that. Should have a horizontal tangent line right here. It should be level. After that point, we are still increasing. But this time, concave up, increasing in a valley. I'm going to make this as smooth as I can. Increasing in a hill first, and then increasing in a valley. So we had 2 points on the curve, 2 interesting points, an intercept, and this point which happened to not only be a critical point, but a point of inflection. And the rest of the information all came from the first and the second derivative. So we've done 2 of these so far. How are you feeling about this? Is this okay? It's working? Okay, cool. Great. So let's move on to the next section. I want to reserve some time at the end of class. We'll have some time to start the next section. Section 3.5, limits at infinity. So as I said last time, section 3.5 is not on the second midterm. So up till now, when we've computed limits, we had limit of some expression as x goes to a particular number. Sometimes we've had a limit from the left, a limit from the right, but we've had x go to a particular number. A limit at infinity means we take the limit as x goes to either plus infinity or the limit as x goes to minus infinity. And what this means is x goes to plus infinity. This means as x gets very big and positive. And as x goes to minus infinity, that means as x gets very big and negative. So sometimes it's pretty clear. Let's take a look at the following example. Let's say the limit as x goes to plus infinity, x gets very big and positive, of x squared. As x gets really big and positive, what's happening to x squared? I mean, if you take a big positive number and you square it, what do you get?
A bigger number.
Yeah, big positive number. So as x gets very big and positive, so does x squared. And What about the limit as x goes to negative infinity of x squared? If you take a big negative number and square it, what do you get?
A bigger positive number.
Yeah, a big positive number, right, exactly. So this is also plus infinity. So basically what you're saying is when you look at the curve y equals x squared, all we said over here is as you take a long walk off to the right, the y values go up to infinity. And this says as you take a long walk off to the left, the y values go up to infinity again. That's all that's saying. That's not very mysterious. Let's take a look at one that's just a little bit more interesting. How about the limit as x goes to plus infinity of 1 divided by x? If x gets very big and positive, and I take 1 over x, what do you get if you take 1 divided by a really big positive number?
Fraction.
Yeah, you get a fraction, you get something that's really small, right? You get, the bigger x is, the smaller this is. Like if I take 1 over 1,000 or 1 over 1,000,000 or 1 over 1,000,000,000, this is getting really, really tiny. This is getting close to, it's getting close to what number?
0.
It's getting close to 0, exactly. And same with the limit as x goes to negative infinity of 1 over x. That's also 0, because if I take 1 over a really big negative number, I get a really tiny negative number. It's getting close to 0. And that would have worked if I had said the limit as x goes to plus infinity of 1 over x squared also. If I take a big positive number, square it, I get a really big positive number. If I take 1 over that, that is equal to a really small positive number. This is getting closer and closer to 0, and that would have worked for x goes to minus infinity also. So over here, what we had, if you want to look at these two graphically, you know what the curve y equals 1 over x looks like. It's a hyperbola. That's the name of that curve. And you can see as you take a long walk off to the right, those y values are getting closer and closer to 0. That's all we're observing over here. Let's do one where the answer is a little less obvious. How about this? The limit as x goes to plus infinity of, let's say, 2x plus 3 all over 5x minus 1. We knew the shape of 2x plus 3 and 5x minus 1, we could just go ahead and look at it and see what this limit is. We take a long walk off to the right on the graph and see what height we were approaching, if any. But let me show you an algebraic trick that you use in a case like this. What we're going to do is we're going to take this fraction and we're going to multiply it by 1. It's always safe to multiply anything by 1. You don't change anything. And the way you multiply by 1 is multiply by something divided by itself. Something divided by itself is 1. So what we're going to do is multiply the top and the bottom by exactly the same thing. And we're going to take that, the thing we're going to multiply by is 1 over the largest power of x. The largest power of x is x to the 1. So we're going to multiply the top by 1 over x, and we're going to multiply the bottom by 1 over x. x to the 1 is the largest power of x over. Let's see what that buys us. So 2x times 1 over x, the x's cancel, that's just 2. 3 times 1 over x is just 3 over x. 5x times 1 over x, the x's on the top and the bottom cancel, that's just 5. Minus 1 times 1 over x, that's just 1 over x. So we just multiplied this through, and the multiplication distributed over the addition here, the subtraction there. So hopefully the algebra was clear there. Now that looks, at first glance, worse than what we had before, which was just 2x over 3 times over 5x minus 1. 2x plus 3 over 5x minus 1. But it's actually better. Because remember, x is going to plus infinity. So x is getting really big and positive. So as x gets really big and positive, what happens to 3 over x? If you take 3 and divide by a bigger and bigger number, what do you get? You get something close to what number?
0.
0, right. If I take 3 and divide by a bigger and bigger number, if the denominator gets bigger and bigger, this is going to 0. And same with the 1 over x. As I take 1 and divide by a bigger and bigger positive number, that's going to 0. So this is going to 0, that's going to 0. 2/5 finished. What we've just determined is that the curve y equals 2x plus 3 all over 5x minus 1 has a horizontal asymptote at height y equals 2/5. Once you realize that, it might jog your memory of being in pre-calculus, or whatever your pre-calculus class was called when you took it, functions, mathematical analysis, high schools, and had various names for this class. You were almost certainly given a technique for finding horizontal asymptotes without any justification. And just a quick and dirty way of doing it. Maybe somebody said to you, you know, the top and the bottom have the same degree, which they both do here. They both degree 1. You just take a look at the ratio of the coefficients of the largest power of x. That might be something that sounds familiar to you. This is why it works. This is why it works. Let's just do one more. How about the limit as x goes to minus infinity of 2x squared plus 3x plus 4 over 5x squared plus let me just change that a little bit. 6x squared plus 7. And we're going to play the same trick we did before. We're going to multiply the top and the bottom by exactly the same thing. This time, 1 over x squared. So distributing through as we multiply, 2x squared times 1 over x squared, the x squareds cancel. We're just left with 2. 3x times 1 over x squared. The x on the top cancels with one of the x's on the bottom. We're just left with 3 over x. 4 times 1 over x squared is 4 over x squared, obviously. I won't say obviously, but 4 times 1 over x squared, that's 4 over x squared. 6x squared times 1 over x squared is just 6. 7 times 1 over x squared is 7 over x squared. Which looks worse, but it's actually better. Because as x gets very big and negative, if I take 3 over a huge negative number, I'm getting something close to 0. If I take 4 over a huge positive number, I'm getting something close to 0. If I take 7 over a huge positive number, I'm getting something close to 0. And 6 are 1/3. So let me just give you a caution. This trick can only be used if x is going to infinity or x is going to minus infinity. So if you think I've given you a shortcut to do all those limits that we worked on earlier in the semester when x is going to a number, regrettably, I haven't. The factoring and canceling thing is still necessary if you have a 0 over 0. The trick with rationalizing the numerator or rationalize the denominator, basically multiplied by the conjugate, that is still necessary in those cases. This trick only works if x is going to infinity or x is going to minus infinity. Now, what I haven't done is answer the question of what happens if the numerator and the denominator don't have the same degree. Again, you almost certainly address that in pre-calculus class, but without any justification. But we're going to come back and do that. I'll do that on Monday. So we have 19 minutes left. I want to talk about midterm 2, tell you exactly what's on it. Basically, like I told you exactly what was on midterm 1. So midterm 2, again, it is closed book, closed notes, no help. But you can ask me if you have a question. And again, I will post it this afternoon, let's say by 2 p.m., and it'll be due by Monday at 9 o'clock a.m. And let's see, due by Monday at 9 a.m. And just like I put a time limit on the first one, I'm going to put a time limit on this one. That's more for my benefit than yours. By that, what I mean is, if I put a time limit on it, then I don't write crazy long exams, which is something I tend to do, because if I don't put a time limit, then I suddenly want to put interesting questions on the exam, which is a really bad idea. Interesting questions are good for the homework, not so good for the exam. So let's see. So what did I have for the first one? Was it an hour and a quarter, I think, including the upload time? I think we'll stick with that. So 1.25 hours to do once you start. So including upload time. And I was very, very grateful that most of you on your first midterm put all your pages in the same file. That was really, really helpful for me when I was grading it. I hope that you'll do that again. I hope you'll name it midterm 2. That was also very helpful, rather than letting your phone assign it some weird, 16 character name or whatever it is. If you would name it midterm 2 or something like that, something that's clear it's a midterm 2, and if you would put it all in one file if you can, that is super helpful, and I would really appreciate it. Okay, what's on it? That's easy. Remember on the first midterm, there was a question where you had to take a bunch of limits. This time there's going to be a question where you have to take a bunch of derivatives. You can use the derivative rules. You don't have to do the limit as h goes to 0 or anything of that. So take derivatives using derivative rules. Take derivatives using derivative rules. So derivatives of power functions, of exponential functions, of logarithm, of sine and cosine and tangent, and the product rule, the quotient rule, the chain rule, and any of that stuff. There will absolutely positively be a related rates problem. There's going to be a little bit of theory on here. I can ask you to state either the extreme value theorem or the mean value theorem. You should be able to define what it means for f to be increasing on an interval I Remember, the definition does not involve the word derivative. Doesn't involve the word derivative. You can write the definition the way I had it in class, given x1 and x2, where x1 is less than x2, then f of x1 is less than f of x2. And those are not the endpoints of the interval. Those are any 2 points in the interval. So how, as I had it in class, you can say it in words. You could say, given any 2 points in the interval, the point on the right always has the higher y value. So words is fine, symbols is fine. It's a little bit shorter in symbols, but maybe more intuitive in words. It's up to you. And you should be able to prove, we did this proof in class, that if derivative is positive on an interval, f is increasing on the interval. We did that proof in class. All you have to do is figure out what we did and be able to reproduce it. So take derivatives, related rates, a little bit of theory, and do what we've just been doing. So given a function f, I'll even organize it on the page like this. So A, where is it increasing and decreasing? Critical points. And you'll have to classify them as max, min, or neither. Concave up, concave down. Points of inflection. Intercepts. Whoops. And graph. Just like we've been doing. Now, when I look at your graph should be based on what you've determined prior to that. I need to be able to see all your work, and I need to see that your graph is based on what happened. If you mess, parts A and B up, and your graph is based on what you messed up, I'm not going to take points off twice. If you sort of correctly interpreted your mistake over here when you were drawing your graph, I'm going to give you full points for the graph. Right? Your graph should be based on A, B, C, D, and E. If all this stuff is messed up and your graph looks, perfect, I'm going to go, something's wrong here. It's not based on the work that they've done. It looks like they've just used their calculator to graph, which of course doesn't get any points because for one thing, you're not allowed to use your calculator to graph. So then you get no points for your graph. So make sure your graph is based on the work that comes before that. I won't take points off twice if you've made a mistake up here, especially if it's just an arithmetic mistake, which I don't take very many points off for. And your graph is perfect based on the information you have up here. I'm going to give you full points for your graph. On your graph, make sure that you mark intercepts. Make sure that you mark your points of inflection. Make sure that you mark your critical points. I should be able to see those all on your graph. Those are the important points, and I should be able to see them. So I am telling you right now, your exam will have 4 questions. One question will be take derivatives. One question will be related rates. One question will be sum of this stuff. And one question will be that. I am telling you basically exactly what's on your exam. I don't guarantee they'll be in this order, but I don't think you care about that. You can do them whatever order you want. What are your questions?
So there won't be any questions on I think it's, what is it? Implicit differentiation.
I would love to put implicit differentiation on the test, but I don't want to make this a race against the clock. And so I'm going to have to make a decision. Usually I'd say study implicit differentiation also. And then I'd have to pick, and you'd have to just get lucky if the things you know best were on the exam, but I am not going to do that this year. So I will tell you that implicit differentiation will be fair game on the final exam, but I am going to just tell you, I'm just telling you exactly what's on the exam right now. Other than I'm not going to tell you what function I'm picking over here. I'm not going to tell you what related rates problem, I'm doing. I'm not going to tell you the things that you have to take the derivative of, and I'm not going to tell you which of this stuff I'm doing. But it's a great question. I am not going to put related rates. I'm sorry. I'm not going to put implicit differentiation on the second midterm. I just don't have space for it.
I have a question. So for the review test and the first midterm, have you graded those yet? Or?
Oh yeah. Sorry. So that was part of your midterm grade. The only thing I haven't done is scan them and get them back to you. So your midterm grade was based on your first midterm and your review test. That's all.
Okay. Did you email that to us? I must have not seen.
No. You're absolutely right, and I wish I had. It takes forever to scan these things and get them out to you, and so hopefully I can do it very shortly. But yeah, it's all graded, and your grades are all set.
Okay. I also have a question about homework. So
yeah,
like when doing the homework, a lot of times like I'll like for the first couple weeks, I would just like I would try it, and if I got it wrong, it'd be like if it would be like 3 questions, and I got like 2 of them right. That's like a 60 on a homework, but like then it would let me click the back arrow and go back and redo them, and I got them right. I'm just wondering like how the homework works, and if it's like if it's a 1 question and I get it wrong, is that a 0 for that homework?
Okay,
Or
so let me tell you how I grade the homework. So it may be that some of you, when you got your midterm grades, got a higher grade than you were expecting. That might be for a couple of reasons. One, when I grade your homework, what I do is if you've done the homework at all, you've already got 50%. Okay, and then so if you get half the questions right on the homework, you have 75%. If you get them all right, you get like 100%. So you get 50% just for doing it, and then the rest of the points for getting things correct. Secondly, and if you want to take advantage of this, you can go back and do it now even. What I always do is look at the best of your first 2 attempts. So if you've only done 1 attempt and you want to go back and do another attempt for all of them, feel free and go ahead and do that. But you can always do the homeworks. As I said at the beginning of the semester, you can do the homeworks as many times as you want. If there's nothing, I don't have anything in the system that'll stop you from doing that. But I will count the best of your 2 attempts. And you can go back and do a second attempt or a third attempt now. When you're studying for your final, you can do them all over again. That's totally fine. So feel free to use those as part of your studying. Let's see. Did I answer your question?
yeah, that answered it.
Okay. What other questions do you have?
I have a question. So we already got 1 midterm grade, right? So this
You have-
midterm, how would it affect it? Like, would it be a different grade, or would it affect the previous grade that we already?
Oh, no. So the midterm grade that was returned to you in my class was the same as in all your classes. It was just a sum total of all the grades that I had for you up to that point. The midterm grade that you get in the middle of the semester, for those of you that are first-year students and are new to this, that is only for your benefit. It goes to you and it goes to your academic advisor. It doesn't get recorded anywhere. It doesn't ever become any part of your transcript. It is just to give you feedback. So if you got a B, you just know that up until the time I recorded that grade, based on your first midterm and your review test and the homework that I had for you up to that point, you had earned a B. But it doesn't, as I said, it doesn't get permanently recorded anywhere. It just gives you feedback as to how you're doing. As I recall, most of you were doing quite well. And so that's great. If you ever want updates on how you're doing, send me email and I can forward, basically the grades that I have on your test to you. That's totally fine. Let's
Can
see.
you do that for me? Because I literally I don't know what my grade is because I haven't been able to find it. Like, I remember you saying you're gonna post on the Google Drive in the same folder, the video, your grade you got on the terms, and I didn't get either of my review test or my midterm.
That's because I haven't done it. That's because of the scanning thing. So I will get both of those scanned and back to you. But let's see. But at any point, you can always send. So I have a grade book, and all your grades are in there. And at any point, you can always just send me email and request, your grades on this and this and this, or whatever it is you want. And at some point before the end of the semester, I am going to send you email and say, I have your homework grades for these homeworks, but I'm missing this one, and I'm going to give you a chance to redo the one you missed. There'll be a penalty for a late homework, as I explained on the syllabus, but you'll still get a chance to change zeros into things that are not zeros, which obviously is better. Let's see. Have I answered everybody's question so far? Okay. If you have any more questions, let me know. And again, yeah, please.
About the third point for the midterm 2, what should a proof contain?
So we did this in class. Basically, remember for this proof, we said, you know, the function, this is in your notes, directly in your notes. Basically, I'm just asking you to understand it and give it back to me. So we had f is continuous on whatever a, b, and f prime is positive on a, b, and you're supposed to show that f is increasing. And your first, in your notes, like your first step is let x1 and x2 be somewhere in, I think, AB, where x1 is on the left and x2 is on the right. And ultimately, you want to show that f of x2 is bigger than f of x1. And we did that using the mean value theorem. So I won't have time to reproduce it for you right now, but this is all in your notes. And assuming that you weren't taking notes that day, it is all in that day of class, which is probably the day we did the mean value theorem and talked about increasing and decreasing functions. So I guess as much as I would much rather have you here in a class, I suppose the upside of doing it this way is every single thing that I said is preserved for you whenever you want it. Are there any other questions? Okay, let me know if you have any questions that come up later. Good luck on your first midterm. Have a great weekend, and I will see you all on Monday.
Thank you. Have a good weekend.
Thanks.
Thank you.
My pleasure.